Okay, we've got a position function that's given by 2t cubed minus 5t squared plus 3t plus 4. It's given in meters and seconds, and we want to find the velocity and acceleration function. If you remember, we already learned that the derivative of the position function is velocity. So to find the velocity function, we're just going to go ahead and take this derivative using the power rule. So bring down the power, reduce the power by 1, do each term separately. So this is my velocity function in terms of t. Now, the change in velocity with respect to time is the derivative of the velocity function, and that's going to give you your acceleration function. So if you go from position to velocity, the first derivative, that'll get you your velocity. The second derivative of the position function is actually your acceleration function. So to get to the acceleration function, I can just take the derivative of velocity. So this would be 12t minus 10. Okay, next, at what point does the graph have a horizontal tangent line? So a tangent line is your derivative. Horizontal, the slope of a horizontal tangent line would mean that the derivative of that function is 0. So we're going to take the derivative of this function, which is 4x cubed minus 12x, and set it equal to 0. And I want to know at what points does this happen. So I can factor it. And all the x values where this is going to be 0 is 0 or plus or minus square root of 3. Now notice it does ask for the points, so we want the x and the y value. So at 0, I'm going to plug it back into the original to find the matching y value. And if I do that, I get 4. And I could do the same thing with plus or minus square root of 3 into the original right here. And you're going to get the same y value of negative 5 here. So there are 3 points on this graph, and it looks something like this, where you would have a horizontal tangent line. Okay, next, given a function x cubed plus kx, k is a constant, we don't know what that number is, and there's a line, we want to find the value so that the line is tangent to the function. Now we don't know exactly what this looks like, but this is a cubic of some kind, and I don't know exactly where it's tangent, but let's say it's tangent here. If I want a curve and a tangent line, they have to have 2 things in common. Notice they have to share a point, and then the tangent line and the curve have to have the same slope. So the 2 conditions are they have to share the same point. So in order for that to happen, the y values have to be the same. So I have to set them equal. And then in order for it to be tangent, they have to share the same slope. So I'm going to take the derivatives of each and set them equal to each other. So now I'm solving this system. I'm going to start by solving this one. So if I solve for k, k is 6 minus 3 minus x squared, and I can plug it in here. And if I do that, this is my equation in terms of x that I have, and now let's go ahead and solve this. I'm going to distribute that x. Minus 3x cubed equals 6x minus 2. I have negative 2x cubed. Bring that 6x over, and then I have plus 2 equals 0. You can factor this out. So the only value where this can occur is when x equals 1. But notice it is asking you to find the value of, x equals 1. It is asking you to find the value of k. So I can go ahead and plug it back in here. So if I plug in 1 here, my k value that I'm looking for is actually 3. Okay, lastly, I want to find a and b such that this function is differentiable everywhere. So remember we learned that the word differential means that the slope exists everywhere. So when these 2 pieces connect, parabola and the line, we want it to be a smooth connection. We can't have a corner, otherwise it won't be differentiable. And in order for it to be differentiable, we also learned that it has to connect, so it has to be continuous. So really, these 2 conditions have to be true. It has to be continuous, so they have to connect, so they have to be equal, and they have to connect at 1. So if I plug in 1 for x, I get this. And then in order for it to be differentiable, we need the slopes at the point where they connect to be the same to create that smooth curve. So the slope of each piece should also be equal. So I know 6x is equal to a, and the x value again is 1, so we found our a. And then plug it in here. So if I plug in 6 for A, B ends up being -3. And try B on your own, pause the video, and then you can come back and check your answer. So for B, you would do the same thing. Set them equal, and then take the derivatives and set them equal. And if I plug in -2 for x, I get 24 plus 24 is A, so A is really 48. And then plug in the A here, and plug in the -2 for x. And if you solve this, simplify everything out, you should get 64.